Hello, Marauders. Tom Cruise here, flying my Super Hornet for Top Gun. Actually, just Mr. Noel here. Today we're going to continue our statistics. We're going to look at best fit lines. Okay, here's our first slide. We're going to talk about correlations. Okay, let's look at this first graph. Positively correlated. Okay, so this is a graph of people going to the water park. And here is the temperatures, and here's the number of visitors that went. And what you might notice is that when the temperature was cold, here's the amount of visitors. And you kind of look over to the side, and okay, it's like 40. Actually, it's in thousands. But as the temperature goes up, what do you notice about the dots? Well, they seem to go up also. So as the temperature increases, so does the amount of people that go to the water park. We say this is positively correlated. As there's more of this, there's more, I'm trying to write more with my finger, there's more of that. So more of this, more of that. More input, more output. More temperature, more visitors. We say positively correlated. If a two lists of data down at the bottom here, if two lists of data go up together, we say they are positively correlated or positively associated. They seem to be related. The temperature seems to affect how many people go to the water park. That makes sense. What's another thing you can think of? Let's put something else in here. Give me something else that the more you do of this, the more of this happens. Okay, pause the video and think of something for a moment. All right, welcome back. So normally it'd be fun to hear all you guys say the different things. Here's one I come up with. How about study? The more you study, the higher your grades, right? The more you study, the higher your grades. Okay, how about negatively correlated? The more of this that happens, more of this, but then we have less of this. This tends to go down. Going down. Think of something. Let me give you a moment. Pause the video. Okay, hopefully you came up with something. Here's one I thought of. How about smoking? The more cigarettes you smoke every day, life, the less you live. More cigarettes, the less and less you live. You can come up with some other things too. How about like more TV? Then you could say something like this: less grades, less friends, because you're watching TV instead of being with your friends. Okay, hello, Mr. Contreras. And you're right. How about this one? No correlation. Think of something that, well, look at the dots. Here, this one was going down, negative. In fact, isn't that kind of like a negative slope? Isn't the slope M negative? Well, positive. This was positive slope going up. This was negative. No correlation. Think of something that these have nothing to do with each other. Give you a moment to come up with something. All right, welcome back. How about this? I could think of something maybe like the more you study and length of your hair. How about that? The more hours you study, the length of your hair, they don't seem connected. There's no correlation. Like somebody studied for 8 hours and here's the length of their hair. Well, here's somebody studied and the dots are all over the place. We could come up with a lot of things. How about number of pencils, like in your backpack, and then how tall you are. There's no connection to how many pencils you have and how tall you are. Okay, here's some other ones. How about this? You tell me what correlation there is. Here's the United States debt. Here's the years as they go by, and here's the amount of dollars the government owes, like if you borrow money. Okay, you should probably notice that it's going up. So we're going to say it's positively correlated. More years, more money we owe. And this one over here is the last one. New color. The men's 1500 meter Olympic gold medal times. Now it doesn't say what they're doing. Are they running? Are they swimming? Maybe it's the 1,500-meter crawl. Okay, here's the years, and here's the time in seconds it took to win the race. And what do you notice? Well, it seems to be going down. As the years go by, more and more years, but less and less time. Actually, thinking about this graph a little bit more, we're going to say this is negatively correlated. Negative. But what about this dot here? If I were to try to draw a line through that, I'd probably go like that. Would I try to hit that dot? Let's call that an outlier. We can use the O right there. That's an outlier. He's kind of in the outside. Well, I'll ask you a few more questions looking at this data. As the years go by, the time to win the race gets less and less. Why is that? As the years go by, it gets less and less. Think about it. Well, there's probably a lot of reasons as the years go by. And what to think about a little more before I say. And also, let's look at this dot. This was the very first Olympics. This is 1896. And the winner, wow, it took them a long time to win. They weren't very fast, yet they won the Olympics. Any reasons why? Okay, how about this? Being that this was the first Olympics, nobody really cared. Somebody said, hey, let's get everybody around the world and we'll all compete to see who's the fastest. And a lot of people are probably like, well, I don't know, I don't care. So in this first one, not a lot of people showed up. It just wasn't much competition. So so many countries, they didn't even send anybody. So when you got there, the competition was pretty easy. Here's another thing. Being that it's 1896, and the first one I believe was held in Greece, you might say, hey, I want to go. I'll just take a car. Wait, cars weren't invented. I'll just fly to get oh wait, there's no airplanes invented. Even if I wanted to go to the Olympics, how would I get there? So just, I say, not many people showed up. But as the years go by, to win, you had to be faster and faster to win. Some of the reasons, well, same reason for this. More and more countries are joining. And each year, more and more people are competing. More and more countries say, hey, we can compete. We want to be in it. And also, more and more people, they can find more and more people. Back then, even in here, there's lots of people that were probably good, but they weren't able to get there. But now there's more and more. Each country is like looking every single town, every single high school, trying to find the fastest people. And more countries are getting there. Other things that have made the speeds get better. So not only is there more competition, but there's also better nutrition, better exercise, better doctors, all types of training get faster and faster, maybe even steroids. So let's go to the next page. So when you're talking about the causation, many reasons. Next slide. Okay, best fit lines. Okay, often we like to come up with an equation that sort of matches our data on a graph. It could be a curved line or a straight line. We'll use a straight line linear because it's the easiest to do. But some complicated data can only be modeled well with a curved line, such as exponential. In fact, remember we did the graphs for population growth, and we had like a graph like this, and we said, here's the world population. It was slow, but all of a sudden, whoa, the world population is going up and up and up. Same thing, we were talking about this coronavirus. It was really low, but you've probably heard now it's more and more people are going and getting it, and it's going up. As time goes by, it's the number of people with coronavirus is going up and up. Also, the amount of new cases each day, though, is starting to kind of level off. So we can't always use a straight line to model it. Sometimes we have to use a curved line, or sometimes it's exponential. But for our work, to keep it simple, and what explains a lot of things, is we are going to use a linear or straight line. Linear as in line, straight line. We're going to call it our best fit line. Let's try it. Okay, so here's some data. It says draw a straight line that best fits the data. So when I look at this line, you try to draw a line right through it. So I'm going to go something like this. There we go. That's pretty good. Now you might say, oh, I think the line should be a little higher. Maybe a little, no, that'd be too low. That'd be too high. Or maybe it should bend a little bit. Okay, but either way, you try the best you can and you just call it the best fit line. Is there a way to actually know who has the best line? Well, there is something kind of complicated to do called the least squares line. And this is an official way that it would be done. But we're not going to try to do it because this is what it entails. To determine who actually draws the best line, you're supposed to measure the distance each dot, every single dot, is from the line. So you just like measure every one of these dots. There's a whole bunch here, right? We had to do them all. And you say how far each one is. Like this guy's like, maybe he's like 0.1. And this guy's like 0.5, you know, and you go through them all. Maybe this guy's like 2 away. You take all those numbers, then you square every one of them. You square them all. Like 2 squared is 4. So you find all the distances, you square them all, you add them all up, and you come up with a total. And whoever has the lowest total wins. They have the best line. This would take forever of you drawing lines and trying to add up all the squares. So they use a computer to do it. A computer can sit there and analyze it. And despite all the work the computer does, we find out it's not much different than if you just went here and just took your best guess and said, about there. That's where the human mind can easily challenge a computer. So anyway, we draw a line, best fit. And now, can you tell me the equation of the line? Let's come up with the line. Sure. How do I go like this? Y equals, okay, what's the slope? Let's look at the slope here. It looks like, well, and we got to come up with a slope. But it looks like, well, it looks like I'm touching about 9, and we're going to go down and over. It looks like I'm going to go down 9 over 10. So I'm going to say, this is hard to write in here. I'm going to write negative, it's going down, negative 9 over 10x plus b. And where's b? Where did I put the beginning? I said it started at 9. There you go. There's the equation. Is it perfect? No. But is it pretty good? It's pretty good. Yeah. Negative 9 or 10s. Okay, so for another one, I drew in my line here. But I didn't go all the way to the end. There's a little problem here. See this gap right here? I can't really go all the way to the end because there's part of the graph missing. So I only drew this part in. And so I'm going to look at the ends, this part right here, and this part right here. Because I got to use the actual stuff. Normally I could go all the way to the end, but I'm going to go between 60 and 100. And then as I look at this, I'm going to go up. So from this dot, we'll go up and then over, and we'll figure out our slope. So we'll put our numbers in. Y equals, how much does it go up? Be careful. Don't go 1, 2, 3, 4, 5, 6. Look at what you're at. What is this number? Look at these numbers. What are they counting by? This over here, this is like 65. And this over here, this is 20, 25, 30, 35. This is like 33. So it goes from 33 to 65. Don't say 1, 2, 3, 4, 5, 6, 7. 33 to 65 is like 32. So it goes up 32. And then over, from here to here, from 60 to 100 is 40. So I got my equation, 32 over 40x plus, and for the beginning, this is my beginning right here. So this kind of creates a little confusion here too. Well, my beginning is 33. Normally I extend it to the 0, but I can't really do it. So it's a problem for this one. So I'm trying to say the beginning is like 33. But so I got my equation. And of course, I could use my equation to predict the future. Like if the temperature were 110, I could plug it in here and see how many visitors I would expect. Okay, let's go to the next slide. So like I said, this one, this creates a confusion here. Okay, here's some data, some shows the weight losses of 10 people on the same diet. So here's a bunch of people, how many months they were on the diet, and how many pounds they lost. So these people wanted to lose weight. And just by looking at this data, what do you think? Is there some connection between the months and the pounds? So we put them in a graph over here. Here's the months. Notice we counted nice and even, never skip numbers, 5, 10, 15, 20. And over here, we took this data. So kind of like this first person, 5 and 18. 5 and 18, they're right there. Notice we counted nice and even, 10, 20, 30, 40, 50. This person, 2 and 2, well, there's 2 months, 2 and 2. So now if you look at the data, is there a correlation? Answer these 3 questions. Do months and weight loss seem related? What is the correlation? And you come up with the best fit line. Okay, let me wait for you. Pause the video. Okay, welcome back. As I put my line in, I try to come up with the best line I can. And, well, I can actually start this at 0, because if you're on 0 months, you lose 0 pounds. Here, where's it good? Maybe, actually, it kind of looks like it goes right to the corner. Maybe I'll bring it over a little bit. Maybe about there. Okay, that's my line. Okay, so do they seem related? Yes, I would say there's definitely a positive correlation or association. The more months, the more pounds. More months you're on the diet, the more weight you lose. What correlation? Positives. Related? I should actually just say yes. Write a best fit line. Y equals the slope. This one's pretty easy. Go up 80 and over. I stopped here about 23. So I'm going to put up 80 over 23. X plus, well, 0. And now if you're comparing to your friend, if your friend puts something different, you know what we should do? Get rid of this ugly fraction. Why don't we divide it? 80 divided by 23, on my calculator says 3.47. So how about I just put I'm going to round off to 3.5x plus 0. Now I got a better equation that I can compare with my friend, because they're not going to put exactly these numbers, but whatever they put, when they make the decimal, they probably said, oh, I got 3.6 or I got 3.4. And so, but at least we all agree. It looks like what this tells me is that every month you're on the diet, it looks like you lose 3.5 pounds. So you could plug in any number you want, put it in, and you'll figure out how much weight you lost. Makes sense. It's a direct variation, isn't it? It's a positive association. Next graph. Here's once again, write the best fit lines. So I'll give you a moment, come up with the best fit lines. Okay, welcome back. I'm going to draw my line. You don't have to stop here. If you extend it, makes it a little bit easier to do. And same with this one. Should I try, don't always go from the beginning to the end. That doesn't look right. You know what? I should just ignore this dot right here. Just forget that dot, because that's just outside. But we should get maybe about there, and then I'll extend it, depending on where you want to put it. I'll just put it about right there. Okay, so now I'm going to write my best fit lines for this one. Y equals, and what's it go up? Don't say 1, 2, 3, 4, 5, 6. You'll be totally wrong, because look what it's counting by. This looks like 5,000, and this is like 11,000. So from here to here, that's up 6,000. This is supposed to be equal 6,000, and across, well, that's 10. X plus, and I started at 5,000. And I could reduce that, so I'll rewrite it. I'm going to write it as y equals, if I divide 600x plus 5,000. That looks like a better representation. So then I can put in the year and figure out what the debt is. And so as the years go by, I'll just put in bigger and bigger numbers, and I can figure out where the debt's probably going to go. Looks like it's going in a straight line. And we'll do the other graph over here. So once again, I'm going to go y equals, I'm not sure here. Uh-oh. There's a gap here. See, this one makes it hard to do already, because this, I can't really use this because this is all off. So doing this one, I really got to just kind of look at this dot to this dot, but I can't really predict the B. I can sit here and manually plug in the points, but it's going to be hard to do. I can do the scale, but I can't really come up with a good line, because once you got a gap here, it's hard to see B unless you go and calculate it. So let's go to the next one. Check your understanding. Okay, you guys try this one. Multiple choice. Which one of these is the best line? I'll give you a moment. Okay, let's see what you got. I want to put a line in here. Well, it's kind of hard to do, isn't it? Yeah, it's a lot of dots, but it does look like it's positive. It's definitely going up. So as I look over here, I can already say, well, it can't be that. Oops, yeah, you can't see it. This one, that's got a negative, so that guy's out. And then let's look at some of this other stuff over here. Okay, so this is a problem, negative, so he's out. What about where did we start? Look at these numbers. Well, if I look at 0, go up to the y-intercept. Right there is the y-intercept. That looks like 3. Okay, it's close to 3. So this guy's out. So it's one of these two. Which slope does it look like? Up 2 or up 1 over 2? Well, let's just grab a point on the graph. How about right here? And maybe I'll go to, I don't know, let's go right there. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, negative 3 to 8. Yeah, I'm going to go up 11 over, from here to here is 1, 2, 3, 4, 5, 6, 7, 8. Up 11 over 8. Well, this is definitely bigger than that. So I'm going to go with this one, up 2x over 3. It's not like up 1 over 2. If I look at the graph again, you know, if I pick somewhere up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, yeah, that's not really working out. It's more like up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2. Hey, that is it. I'm going to go with A. Next graph. Once again, you do it again, I'll wait for you. Okay. Okay, so on this first one, to me, I'm looking at this right here. I see like 7, and I'm like, this is pretty close, 6 and 7. But this answer is actually better. The slope, negative 0.6, that's kind of close to negative half, and that looks a little better as you kind of go through it. This one over here, this one's a little tougher. This looked too much, 9. My graph, I'm kind of in here. I'm saying, well, that one's no good. How about 6? But then again, there's 5. Wow, that's pretty close. And this was 4.5. So which one's better here? I'm going with C, negative 1/2 x plus 6. You can actually go back and try to draw some of these in. If you wanted to like actually draw it and go, let me just see, 9, and the slope's down 1. So down 1 over 1, down 1 over 1, down 1, down 1. You could do that and try to put that in there and kind of go, if I started at 9 and went down 1 over 1, you know, it's not quite. But you could try the different ones, but I thought this one was pretty good. See, starting at 6, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. That looks pretty good, so I went with choice C. Okay, and here's the last challenge. Can you guess a line of best fit without graphing? There's 4 of them for you to do. So let me give you some time. Go ahead, pause the video and come back. Okay, this could be challenging. Let's look at this first one. I'm trying to come with the first one. Let me just go right here. Y equals. Well, how would I just do this? So it goes 1, 2, 3, 4, 5, and it goes from 2 to 12. How about we just do it like an old slope thing? Here's the x, here's the y. We're at 2, and we go all the way to 12. So the change in y is 10. It goes up 10, and from 1 to 5 is 4. So this was 10, this was 4. Oh, that's that. I just did the old-fashioned way. Plus in the beginning, wait, not 1. You have to go 5, 4, 3, 2, 1. What would be in at 0? 12, 9, 2. Looks like it's going about 2 or 3 each time. And looking at it, I'm going to say negative 1. So I'm going to change this to -1. Looks like it does 3, 2, 3, 2, 3. So I'm going to put that, I could rewrite it as 2.5x minus 1 also. Okay, so that strategy works. Let's try the next one. I can do the same thing. From 1 to 8, that's up 7. So up 7. From 2 to 13 is 11. Y equals 7 plus, and once again, I'll go back to 0 and kind of look at this pattern, 13, 10, 3, 5, 2, 0. And this seems kind of easy, 2, 2, 2, 2. Well, let's go back 2 more, -1 again. All right, -1. Okay, so that's pretty good. My strategy all is going to work? Okay, let's see, from 0 to -10. Wait a minute. Check out the numbers. Wait, this number looks weird. These are all positive. Where did the heck -10 come from? I don't think it's going to work. This is really confusing me. So, in fact, I went and graphed these. No matter what you come up with, you're really going to have a hard time doing this one. Okay, so I gave up. I went and, it says without graphing, but this doesn't make sense. Why is it at 0? It's positive. Now it's negative. It's just completely confusing. I put them on the graph. Here they are. And then when I go, well, that's not a straight line. So I connected them. And it goes here, then here. I go, wait a minute. That's a parabola. That's an upside down parabola. No wonder I can't figure it out. It's some type of -x² graph. A straight line's not going to work at all for this one. We could even get fancy if you remember, go negative, parentheses, x. It seems to be peaking, or the vertex, at 4, 8. So remember we did x minus 4 plus 8. Put the little square in there. There's your graph. That's my equals. That's my minus, because it's an unhappy parabola. Remember that? The vertical translation. So this was like not even a straight line. Okay, and there's one last one. This one here. Well, I'm going to graph it anyway. Let's just see what happens when I do graph it. 1, -5. So I'm going to give in 2, -1, 2, 2, 3, 4. Hey, this is not a function right here, is it? But let's just see what happens. 4, 9. Well, it doesn't have to be a function. It's still some data. Oh yeah, I guess this is a straight line. So yeah, we could come up with a straight line. Y equals, and maybe I'll just go from here to here. Well, that's up 14. From 1 to 4 is 3. 14/3 x plus, and seems to cross around here at -5. So I'll put plus -5 or -5. Once again, you could change that to a decimal. Okay, so those are pretty challenging. We'll do this tomorrow, so that's it for today. But if you want misleading statistics, lies, dang lies, and statistics. Okay, hope you enjoyed the videos. Goodbye, guys.